Hi everybody, Seth Wilkinson from the SealRyt Corporation, manufacturers of the PackRyt bearing and high performance mechanical packing. Today I'm going to be talking about evaluating failed packing. Evaluating failed packing is a process by which you remove the packing that has failed and do a detailed analysis of what you find, which will determine your root cause of failure. Determining that root cause of failure is key in indicating whether or not you're using the proper type of packing based on the process which it is in, the speed and mechanical conditions of the pump, as well as if you have a proper amount of flush, flow, and pressure. One of the key things that you want to do when you are removing packing that has failed is to make sure that you remove it in order with which it was installed. This will allow you to determine at what point in that stuffing box that initial failure has been caused. Starting off, we're going to go with embedded solids. So as you look here, embedded solids, you identify which rings have embedded solids, making note of where they are in the order of installation. Embedded solids may indicate the following: solids present in the flush, inadequate or loss of flush pressure, loss or uneven gland load. Solids embedded in the packing leads to packing degeneration and will create leak paths. Keeping the rings in intimate contact during installation, along with adequate flush volume and pressure, will reduce this failure mode. Next is burnt packing. Burnt packing appears to be burnt, indicating glazing or shiny or buildup of carbon created by heat, as you can see here along the ID of this packing. It is most often found in the corners, but it can be found here along where it has contacted the shaft sleeve. Packing material being used may be inadequate for the shaft speed or inadequate flush volume and pressure. Ensure the packing used will perform considering the shaft speed, process temperature, and that the flush is adequate. Next is brittle packing. As you can see, very hard, dense, will not bend. Brittle or hardened packing will have little to no flexibility and can be caused by several factors: incompatibility with processed media, embedded solids due to loss of flush, steaming of flush due to inadequate volume or pressure, or an over-tightening of the gland. Proper packing selection given the percent of solids of the processed media, adequate flush, and proper maintenance procedures can reduce this occurrence. Packing extrusion. Packing extrusion is most often caused by improper clearances between the box, the gland, the shaft, and the lantern ring. As you can see, it's indicated here on the ID of this particular piece of packing where the material and the yarns were extruded underneath several different locations. The top ring, meaning the ring furthest out from the stuffing box. The top ring ID extrusion indicates excessive clearance in the gland ID. So right here, this clearance is too large. Top ring OD extrusion indicates a worn or improper sized gland. That would be here. This is too small. Bottom ring ID extrusion indicates excessive shaft runout, worn bad bearings, or worn box throat, and that is indicated right here. So this tolerance here is too large, and as you apply pressure, it'll cause the packing to do that and extrude underneath. And again, as you can see, it also has a tendency to burn that packing. Extrusion around the lantern ring indicates that the lantern ring is not properly sized. Inspection of the gland, the stuffing box, bearings, and proper sizing of the lantern ring are equally important in the performance of packing. Lastly, you have your soft packing or torn or fractured fibers. As you can see, this one has been through it a little bit. You inspect both the ID and OD of the removed packing for fiber wear. As you can see, there is tremendous amount of fiber wear. This can indicate the wrong fiber is being used or the shaft sleeve surface is damaged. Packing can spin in the stuffing box. This can be caused by over-tightening of the gland, solids embedded in the packing, oversized packing installed in the stuffing box. There could be shaft sleeve damage or shaft movement due to cavitation, runout, or failed power frame bearings. This is exactly what you'll find if a packing will spin right here. It'll cause it to snake and curl up. Soft packing also is something that you may find could indicate a chemical attack from the process, and this is sometimes what you will find as an indicator. Sometimes you won't find any packing at all, but the packing you do remove, the fibers will be soft, frayed, or disintegrated altogether. Another indication of this is that the gland has been taken all the way up during adjustment and the pump continues to leak. With that one, it's simple. You select a packing with the appropriate pH level. So there you have it. Analyzing packing. Some of the benefits, if you do this process, obviously is reducing the mean time between failure of that particular process. It also helps to extend the life of the pump, extend the life of the parts. In certain cases, it'll help with the amp draw, reduce the amp draw on that particular piece of equipment. But most importantly is it will decrease the amount of time that maintenance has to spend on this application, which we all know is a very frustrating element to that job. That's all I have for today, folks. Thank you very much.